This is not a concept sketch or a distant prototype. Northrop Grumman has just unveiled a new AI-piloted fighter drone designed to change how air dominance is achieved from the very first moments of conflict. With no cockpit and no human reaction limits, it operates at machine speed, coordinating and adapting in real time while remaining extremely difficult to detect by enemies. But what happens when AI controls the pace of military power? And who is truly in charge when machines move faster than humans can react? Join us as we go deeper into the technology and the global implications behind this drone. The push to build a cheaper, yet smarter and faster military aircraft has been gaining momentum for years, and one recent project shows just how far that mindset has evolved. Instead of chasing perfection at any cost, the focus is shifting toward flexibility, speed, and affordability. That change in thinking did set the stage for the development of a new autonomous combat drone known as Project Talon. Project Talon was created as a response to an earlier attempt to compete in the Air Force's collaborative combat aircraft effort. That earlier design impressed evaluators with its technical capability, but it stumbled in areas that matter just as much in modern warfare: cost and affordability. The lesson was clear: advanced performance alone is no longer enough. If a system is too expensive or too slow to produce, it risks being left behind. So the team went back to the drawing board with a different mindset. Instead of asking how to build the most advanced aircraft possible, they asked a more practical question: how can you deliver the same level of capability, but do it faster and at a lower cost? From the beginning, the real goal wasn't just a new aircraft, but a better way of designing and building one. That approach paid off quickly. From the moment the project was approved to the point where the aircraft was fully resting on its landing gear, the entire process took just 15 months. That milestone, often referred to as weight on wheels, marked a major achievement for a large uncrewed aircraft. Even more impressive, the first flight is expected to happen within 2 years of the project's start, putting it on track for sometime next fall. In an industry where timelines often stretch into decades, that kind of speed stands out. What's more intriguing is that the faster pace didn't come at the expense of capability. In fact, the aircraft reportedly performs better in several key areas than the earlier design that inspired it. The team not only met its affordability goals, but exceeded them, proving that speed and performance don't have to be mutually exclusive. Much of that progress came from simplifying the aircraft itself. By reducing weight and cutting down on the total number of parts, the design became easier and quicker to build. The drone ended up roughly 1,000 pounds lighter than the earlier version, thanks largely to a fully composite structure. It also uses about 50% fewer parts, which translated into a construction time that was roughly 30% faster. Fewer parts mean fewer delays, fewer supply chain issues, and fewer things that can go wrong during assembly. Another major factor was how the team worked together. Engineers from different groups collaborated closely from day one, allowing them to make smart trade-offs between performance, cost, and schedule. This more flexible design philosophy stood in contrast to traditional methods, which often lock in requirements early and make changes difficult later on. Here, adaptability was treated as a feature, not a compromise. This philosophy lines up perfectly with the broader idea behind collaborative combat aircraft. The concept isn't about building a handful of exquisite machines. It's about affordable mass. These aircraft are meant to operate in large numbers, supporting crewed fighters and absorbing risk in contested environments. In a conflict where attrition is expected, losses are inevitable. That means the aircraft not only need to be affordable, but also easy to replace. Rapid manufacturing becomes just as important as combat performance. Interestingly, Project Talon was not originally intended to be a direct entry for the next phase of the Air Force program. Even so, it has drawn significant interest. Multiple branches of the U.S. military, along with international partners, have taken notice, and some have already traveled to see the aircraft up close. Whether or not it ends up competing formally, Project Talon has already accomplished something important. It has shown that building capable, autonomous combat aircraft doesn't have to take forever or cost a fortune. That early attention becomes easier to understand once you look at what Talon is actually designed to do. Based on the first technical details that have been made public, Talon looks purpose-built for stealth and staying power, rather than raw speed alone. The airframe appears optimized to keep a low radar profile while remaining airborne for long stretches, which fits perfectly with the idea of operating deep into contested airspace. Advanced composite materials play a big role here, not just for weight savings, but also for shaping that helps reduce radar visibility across common tracking bands. All of that points to a design focused on surviving the journey in and out, not just what happens once it gets there. Powering the aircraft is likely a compact turbojet engine chosen for balance rather than extremes. The emphasis seems to be on a solid mix of thrust and fuel efficiency, giving Talon enough speed to reposition quickly without sacrificing range. That kind of compromise makes sense for a platform meant to loiter, scout, and support rather than sprint in and out like a traditional fighter. Some details, like the exact intake design and propulsion configuration, are still under wraps, but the overall direction suggests practicality over flash. Where Talon really starts to stand out is in what it can carry and how it can be upgraded. The platform appears designed to support a variety of long-range intelligence, surveillance, and reconnaissance sensors. Stabilized electro-optical systems capable of delivering high-resolution, multispectral imagery would allow it to spot threats early, track activity over time, or even assist with target designation. In other words, it's built to see more, farther, and longer than crewed aircraft might comfortably manage on their own. That sensing capability is backed up by a flexible avionics setup. An open architecture approach makes it easier to integrate new processing modules or lightweight electronic warfare tools as needs change. Whether it's jamming, signal interception, or mapping the electromagnetic environment, Talon seems designed to plug into evolving mission requirements without forcing a full redesign. This flexibility allows it to expand the awareness of nearby fighters and multiply the options available for deep collection and support missions. Communication is another major focus. Talon is expected to rely on secure, jam-resistant data links that align closely with Western tactical standards. The goal here is constant, reliable information flow. That means sharing sensor data with crewed aircraft, exchanging mission updates, and maintaining the option for human operators to step in when needed. While the exact technical standards have not been fully detailed, everything points toward compatibility with fifth-generation command and control ecosystems. Behind the scenes, a dedicated testing and development environment plays a major role in keeping the program agile. By combining live flight tests with embedded simulations and rapid validation of autonomous software, engineers can shorten the gap between design changes and real-world feedback. This setup allows lessons from complex maneuvers, cooperative missions, or high-stress scenarios to be folded back into the system quickly, speeding up maturity and decision-making. Just as important, the program actively incorporates feedback from operational users across different communities. That input helps ensure Talon evolves alongside real-world doctrine rather than being locked into a single vision of future warfare. Modular upgrades for sensors, communications, or electronic warfare systems mean the aircraft can adapt without disrupting production. That flexibility and user-driven approach also help explain how Talon stayed largely out of sight for so long. While the design was quietly maturing through operator feedback and modular planning, Northrop kept public acknowledgement to a minimum. So when the Mojave event finally marked the first official confirmation of Project Talon, it wasn't the start of the story, but the moment the wider aviation community realized the rumors had been pointing to something very real. Rumors started circulating back in October, when it first appeared in reports under its former name, Project Lotus. Observers quickly pieced together clues, noting that Talon featured a long, slender fuselage sitting forward of the wing's leading edges, an engine intake positioned high near the rear of the aircraft, and sharply angled tails. Early footage from Northrop hinted at a design unlike anything the company had previously shown, fueling even more speculation that Project Lotus and Talon were one and the same. The timing of all this comes as the Air Force prepares for the second round of its collaborative combat aircraft competition, planning to hand out concept refinement contracts in early fiscal year 2026. Northrop is far from the only player in the game, with several other major defense firms quietly developing drones that could become potential offerings. Lockheed Martin's Skunk Works division, for example, has been working on a stealthy combat drone called Vectis, with its first flight scheduled for 2027. While details remain scarce, it's clear the company is exploring options for future unmanned systems that could align with the Air Force's needs. At the same time, General Atomics has been developing a drone known as Longshot under a Defense Advanced Research Projects Agency contract, positioning it as a possible contender depending on how the Air Force's requirements evolve. Even smaller firms are getting involved. Shield AI has been pursuing its X-Bat concept, a stealthy drone with vertical takeoff and landing capabilities, aimed at contributing autonomy solutions to the CCA program. These efforts highlight a growing trend. Unmanned aircraft are no longer experimental side projects. They are becoming central to future combat planning, with multiple companies racing to prove they can deliver systems that are capable, adaptable, and affordable. Last year, Northrop Grumman began flight tests for its Beacon project using a modified scaled composites Model 437, nicknamed Vanguard, to see how artificial intelligence performs in real flight. The effort was part of a broader Pentagon push to trial AI on actual aircraft before eventually integrating the technology into future combat fleets. During the tests, the Vanguard ran Northrop's new Prism software, which handled core flight and safety functions, while giving outside developers the flexibility to plug in their own AI systems. A safety pilot was aboard each flight, ready to take control if necessary. The early missions focused on validating Prism itself before gradually incorporating partner software, with trials continuing through 2026. 6 tech companies, Applied Intuition, Autonodyne, Merlin Labs, Red 6, Shield AI, and Sortech, participated in the first phase. Their systems were tested on tasks like navigation, working alongside other aircraft, and mission planning, giving developers a rare opportunity to trial their software in a live, high-speed environment. Beacon was designed as an open architecture ecosystem, allowing innovators to connect their AI without having to build their own aircraft. This approach lowers the barrier for companies that specialize in autonomy but aren't traditional hardware manufacturers, while ensuring the jet remains safe to operate. The initiative fit neatly with the Pentagon's wider effort to integrate AI across the Air Force and Navy, including pairing crewed fighters with autonomous drones under the Collaborative Combat Aircraft program. Unlike other test aircraft, Beacon's Vanguard was intended to fly more frequently at lower cost, with Northrop providing all telemetry and support systems. The goal was to create a reliable, flexible platform where new ideas in AI and autonomy could be put to the test quickly and iteratively. The Vanguard itself is a single-seat aircraft developed by Scaled Composites in California. It measures roughly 41 feet in both length and wingspan and has a gross weight of 10,000 pounds. A Pratt & Whitney PW535 turbofan powers the aircraft, giving it about 5,100 horsepower. That allows for a top speed of roughly Mach 0.85, a range of about 2,600 nautical miles, and an operational altitude of 25,000 feet. By combining a capable airframe with an open software architecture, Beacon provided a unique environment for pushing AI and autonomy forward. It complements other Air Force experimentation platforms, like the X-62 Variable In-Flight Simulation Test Aircraft at Edwards Air Force Base, and the Viper Experimentation and Next Generation Operations Models, F-16s, at Eglin Air Force Base. But with the advantage of flying more often, testing more ideas, and doing so without the high operational cost of fighter jets. That experimentation-focused foundation doesn't end in the test environment. The lessons learned from platforms like Beacon feed directly into how Northrop is thinking about Talon's long-term role beyond development. Instead of treating it as a one-off demonstrator, the company is shaping Talon as a scalable, deployable system, one that can move from rapid testing to real-world relevance, both for the U.S. military and its partners abroad. A key factor in achieving that speed was Northrop's use of its Beacon testbed ecosystem. By testing Talon's avionics and software in real-world conditions, engineers were able to iterate quickly, identify issues, and refine performance without waiting for traditional development cycles. This approach not only accelerated development, but also helped ensure that the drone would be ready for operational testing sooner rather than later. Talon builds on Northrop's previous efforts for the Air Force's Collaborative Combat Aircraft program. The company had pitched an earlier design for the first increment of the program, but was ultimately not selected, likely due to cost concerns. The new Talon is significantly different from that initial offering. It is roughly 1,000 pounds lighter, uses about half as many parts, and can be built in a process that is roughly 30% faster. By streamlining the aircraft and rethinking the design process, Northrop created a drone that retains high performance while being easier and faster to produce. The result is an aircraft that is not only capable in contested environments, but also scalable enough to meet the demands of both U.S. forces and potential international customers. Talon demonstrates how combining advanced autonomy, practical design choices, and accelerated testing can produce a next-generation unmanned aircraft ready to meet the evolving needs of modern warfare. Even with all of those advantages, Talon isn't meant to signal the end of crewed aircraft. Its development highlights how far unmanned systems have come, but also helps frame their role more realistically within modern air power. As capable and scalable as platforms like Talon are, they represent an evolution in how air forces operate, not a clean replacement for everything that came before. Despite some claims that manned fighter jets are a thing of the past, the reality is far more nuanced. It's true that drones have made enormous strides, especially over the last 3 years, but they remain limited in what they can accomplish. Fully replacing a human pilot across the full spectrum of combat missions is still many years away. Fifth-generation manned fighters continue to have a strong future, but the outlook for sixth-generation aircraft is less certain. Recent announcements suggest that the Air Force's Next Generation Air Dominance Program, or NGAD, is being influenced by political and strategic factors, leaving its ultimate path somewhat unclear. Brigadier General Doug Wickert, who leads the 412th Test Wing overseeing AI piloting technology, has emphasized that human pilots are not going away anytime soon. The military is still many years from fully replacing pilots with autonomous systems, and complete reliance on robotized warfare is likely centuries off. That perspective reflects the current state of AI, impressive in simulations and controlled environments, but still struggling with the unpredictability of the real world. The 412th Test Wing has been experimenting with autonomous piloting through platforms like the X-62 Variable In-Flight Simulation Test Aircraft, a modified F-16 Fighting Falcon capable of flying under AI control. This kind of research informs the development of next-generation loyal wingman drones, including programs like General Atomics Longshot, Northrop Grumman's Model 437 Vanguard, the XQ-67A, Anduril's Fury, and the X-47A Pegasus. These systems are intended to fly alongside manned fighters as part of the Air Force's Collaborative Combat Aircraft Program, giving human pilots additional sensors, firepower, and situational awareness. Even the most advanced AI pilots are still prone to errors that human pilots would rarely make. In tests, autonomous systems occasionally make unexpected or illogical decisions, highlighting the gap between simulated and real-world operations. Similar issues appear in current combat, where autonomous kamikaze drones sometimes mistake terrain or objects for targets. These limitations underscore why humans remain an essential part of the cockpit equation. The future of air combat will not be an either-or scenario of all drones or all manned fighters. Instead, it will be a layered approach where human pilots work in tandem with autonomous systems. Loyal wingman drones will accompany manned aircraft, extending the reach and capability of the fleet while reducing risk to pilots. This complementary relationship will define the next era of air warfare. Humans making critical decisions, supported by drones capable of tasks that are dull, dangerous, or repetitive, all integrated into a single, highly capable combat team. In essence, manned fighters are far from obsolete. They will remain central to U.S. air power, but their effectiveness will increasingly rely on seamless collaboration with autonomous aircraft, a partnership that will define the future of the Air Force. A pivotal era for U.S. military aviation. This was shortly after a chilling wake-up call for American intelligence, the infamous downing of the Lockheed U-2 Dragon Lady. That high-altitude reconnaissance aircraft was shot out of the sky by the Soviet Union, exposing vulnerabilities in U.S. aerial operations. This incident shook the U.S. intelligence community to its core and forced a major overhaul of policies, procedures, and safety protocols. In response, military planners envisioned an ambitious new bomber. The idea was to combine the immense payload and range capabilities of the legendary Boeing B-52 Stratofortress with the blistering speed of Mach 2, similar to the sleek Convair B-58 Hustler. The hope was that such a bomber would outclass anything the Soviet Union could throw at it, essentially rendering their defenses powerless. But this dream collided with a harsh reality. The SA-2 guideline missile, known to the Soviets as the S-75 Dvina, a game-changing surface-to-air missile system that proved devastatingly effective. It was this very missile that brought down the U-2, shattering any illusions of invincibility in high-altitude operations. The United States quickly realized that the age of safe, high-speed, high-altitude bombing was over. In a radical pivot, military strategists decided to change the game entirely. Instead of soaring above enemy defenses, bombers would dive down low, hugging the terrain to evade radar detection. This approach, known as low-altitude penetration, took advantage of terrain masking, a clever tactic where pilots used natural features like hills, valleys, and even mountains to hide from radar. By flying low, bombers could disrupt the line of sight between enemy radar systems and the aircraft, essentially playing a high-stakes game of hide-and-seek. The terrain acted as a shield, making it nearly impossible for radar operators to maintain a lock on the bomber. Interestingly, this shift toward low-altitude flying began even before the U-2 incident, showing just how rapidly tactics were evolving in the face of new threats. In those early days of radar technology, one major challenge was how the systems often struggled to detect enemy aircraft, especially those flying at low altitudes. This problem was made even worse by random reflections from the ground and nearby objects, which created significant interference. These limitations greatly reduced the effectiveness of air defense systems when dealing with low-flying aircraft. Take the B-52 Stratofortress, for example. This iconic bomber was originally designed for high-altitude missions, cruising far above the reach of most enemy defenses. However, its remarkable adaptability turned it into an effective low-altitude workhorse over time. Its massive fuel capacity allowed it to fly long distances even at lower levels, while its large airframe provided ample room for advanced radar jamming equipment and deception systems. These upgrades helped it counter enemy radars and stay relevant despite its aging design. That said, the B-52 was never truly ideal for low-altitude missions. Its size and design made it less maneuverable compared to purpose-built low-flying aircraft. Recognizing this limitation, the U.S. Air Force sought a more specialized solution: a strategic penetration bomber capable of evading enemy radar by hugging the terrain. The first comprehensive study of such an aircraft, called the Subsonic Low-Altitude Bomber, was completed in 1961. This led to the conceptualization of a revolutionary design. Unlike the rugged, militaristic appearance of traditional bombers, this new design looked more like a commercial airliner, with sleek, swept-back wings, a distinctive T-shaped tail, and massive high-bypass turbofan engines for greater fuel efficiency and range. The story of the Advanced Manned Strategic Aircraft began with a predecessor project known as the URSA Extended Range Strike Aircraft. This ambitious endeavor introduced a revolutionary design feature: a variable sweep wing, allowing the aircraft to adapt its wing position during flight for better performance at different speeds. It quickly gained attention within the aviation industry, becoming a significant milestone in aircraft innovation. The URSA project set some bold goals. The aircraft needed to carry a payload of 10,000 pounds and travel more than 10,000 miles. Of this distance, nearly 2,900 miles were to be flown at low altitudes, a challenging requirement given the fuel efficiency and structural demands of such flights. By 1963, all these ambitious ideas coalesced into what became the Advanced Manned Precision Strike System, or AMPS. This program sparked intense research and development efforts, with industry giants like Boeing, General Dynamics, and North American Aviation stepping up to the challenge. A year later, the U.S. Air Force revised its requirements, giving the concept a new name and broader ambitions: the Advanced Manned Strategic Aircraft. Unlike its predecessor, AMSA prioritized high-speed, high-altitude flight capabilities, aiming to compete with the likes of the Mach 2-capable F-111 Aardvark bomber already in service. This change was driven by the need for a bomber that could operate effectively in both conventional and nuclear missions, potentially outmaneuvering emerging Soviet air defenses. By this time, AMSA had become somewhat of a running joke among aviation experts, who quipped that it was America's most studied aircraft. While the project promised innovation, it also highlighted a growing debate within U.S. defense circles. Then Secretary of Defense Robert McNamara was particularly skeptical. A staunch advocate of intercontinental ballistic missiles as the backbone of America's nuclear deterrence, McNamara argued that pouring resources into developing a costly new bomber was unnecessary. After all, ICBMs could deliver similar results at a fraction of the cost and with far fewer operational risks. In 1964, the Advanced Manned Strategic Aircraft Program took a significant turn when it was scaled back to focus solely on component research and development. This decision reflected broader debates about defense priorities during that era. By 1968, the program faced another setback when funding for the aircraft's development was vetoed yet again. However, everything changed when Richard Nixon became president. Shortly after taking office, Nixon reinstated the AMSA program as part of his administration's flexible response strategy. This approach was designed to provide a wide range of military options, steering away from the stark choice of launching an all-out nuclear war. Nixon's Secretary of Defense, Melvin Laird, took a closer look at the program. After a thorough review, he made some pivotal adjustments. One notable decision was reducing the number of FB-111 aircraft, which fell short of the range required for strategic missions. Instead, Laird pushed for accelerated research and development on the AMSA design, aiming to deliver a long-range bomber that could better meet the Air Force's needs. By 1969, after extensive discussions and debates, the program finally gained traction. It was officially named the B-1A project, signaling a fresh chapter in the Air Force's quest for a cutting-edge bomber. That same year, the Air Force invited aerospace giants, Boeing, General Dynamics, and North American Rockwell, to submit their proposals for what would become a new generation of strategic bombers. The process wasn't without its challenges. By 1971, after reviewing North American Rockwell's proposed designs, the Air Force identified 297 requests for design changes. These revisions range from addressing issues of non-compliance with technical specifications to making improvements that would simplify maintenance and enhance operational efficiency. Despite these hurdles, the program pressed on, laying the foundation for what would eventually become the iconic B-1 Lancer. One of the major challenges facing the B-1 bomber program in the 1970s was inflation, which drastically inflated costs. When the program was first conceived, the estimated cost of building one B-1 bomber was around $40 million in the 1970s. However, by 1975, that figure had skyrocketed to $70 million, nearly double the original estimate. This sharp increase in expenses prompted President Jimmy Carter to reevaluate the entire program. But it wasn't just the soaring costs that concerned him. Around the same time, President Carter learned about ongoing work on a groundbreaking stealth aircraft. The concept of a nearly undetectable bomber using advanced stealth technology seemed like a smarter investment to him compared to the continuing development of the B-1. On June 1977, Carter made a tough decision that he later described as one of the hardest of his presidency. He announced the cancellation of the B-1A bomber program. Instead of pouring more money into the B-1, his administration chose to focus on strengthening the U.S. nuclear deterrent through intercontinental ballistic missiles and submarine-launched ballistic missiles, which were seen as more cost-effective and strategically valuable at the time. Despite the secrecy surrounding the stealth bomber program, Carter's decision allowed for the continuation of the Advanced Technology Bomber Project. This highly classified program would later give rise to the iconic B-2 Spirit, a stealth bomber that revolutionized aerial warfare with its ability to penetrate deep into enemy territory undetected. Interestingly, even though the B-1A program was officially canceled, flight testing of the prototypes continued. By the time testing ended in April 1981, 4 B-1A prototypes had completed 70 test flights, logging a total of 378 flight hours. These tests provided valuable data that would prove useful when the program was eventually revived. When President Ronald Reagan took office in 1981, he faced a similar dilemma: whether he should restart the B-1 program to quickly enhance the U.S. bomber fleet, or he should wait for the ATB project to deliver a more advanced stealth bomber. By October 1981, President Ronald Reagan made a bold announcement. The U.S. would move forward with an order for 100 B-1 bombers to fulfill the critical long-range combat aircraft role. Just a few months later, in January 1982, the U.S. Air Force took the next big step, signing 2 contracts with Rockwell International worth a hefty $2.2 billion. These contracts kicked off the development and production of this cutting-edge fleet of bombers. But this wasn't just a revival of the earlier B-1A model. It was the dawn of a reimagined aircraft, the B-1B Lancer. Engineers made significant changes to improve performance and survivability. For example, the original variable geometry air intake ramps, which were complex and heavier, were replaced with simpler fixed intake ramps. This change not only streamlined the aircraft, but also reduced its radar cross-section, making it less detectable by enemy radar systems. While this came with a slight reduction in maximum speed, the trade-off was worth it. The redesign prioritized high subsonic speeds at low altitudes, a critical capability for evading detection and enemy fire during missions. The B-1B could now cruise at Mach 0.92 at low altitudes, an improvement over the B-1A's Mach 0.85. For operations at higher altitudes, its top speed reached Mach 1.25, slightly below the supersonic capabilities of its predecessor, but still impressive for a strategic bomber. Another critical enhancement was its maximum takeoff weight, which jumped from 395,000 pounds in the B-1A to a staggering 477,000 pounds in the B-1B. This upgrade allowed the aircraft to take off fully loaded with internal fuel and still carry additional external weapons if needed. This made the B-1B not just a stealthier bomber, but also a far more versatile and capable one, perfectly suited to handle Cold War-era threats. Due to the dedicated work of Rockwell engineers, the B-1 bomber's weight increase was kept to a minimum, despite major upgrades and design changes. One key factor was the growing concern about the Soviet Union's introduction of the MiG-31, which was equipped with the advanced Zaslon radar system, along with other aircraft capable of look-down capabilities. To counter these threats, the B-1's electronic warfare suite underwent a significant modernization, improving its ability to avoid detection and jamming. The B-1's impressive appearance of the aircraft features a mixed-wing configuration, with a variable sweep wing that can adjust from 15 to 67.5 degrees. This gives it great versatility, allowing it to perform at both high and low speeds with excellent maneuverability. The B-1 also boasts unique triangular motion control keels and a distinctive crosstail design. Underneath the sleek exterior, the bomber is powered by 4 General Electric F101GE102 turbofan engines. Each engine is capable of producing 17,390 pounds of thrust, with afterburners providing an impressive 3,780 additional pounds of thrust for rapid acceleration. In 2004, during discussions about the B-1B to B-1R upgrade, there were plans to replace these engines with the more modern Pratt & Whitney F119 engines, similar to those used in the F-22 Raptor. While the idea was floated by Lockheed Martin, it never progressed to the implementation stage. The survival of the B-1 bomber, especially when compared to its contemporaries in the aviation world, can largely be credited to its relatively low radar signature, or effective dispersion area. While it's far from being a stealth aircraft like the B-2 Spirit, the B-1's design cleverly incorporates features that reduce its radar visibility. For instance, it boasts serpentine-shaped air intakes that help minimize radar reflections and extensive use of radar-absorbing materials on its fuselage. These innovations give the B-1 an ESR that is approximately 1/50 of that of the B-52, even though both aircraft are roughly the same size. To put it simply, the B-1's radar signature is closer to that of a smaller, less detectable aircraft, though it doesn't fully qualify as stealth. Dubbed the Bone, the B-1B Lancer was a formidable threat during its heyday, especially to the Soviet Union. With a staggering range of over 3,400 miles without needing refueling, the bomber could extend its reach indefinitely thanks to its in-flight refueling capability. Its payload capacity was equally impressive, capable of carrying up to 125,000 pounds of bombs, including nuclear warheads. This meant the B-1B could deliver devastating strikes anywhere on the planet with speed and precision. However, timing was not on the B-1 side. When it officially entered service in the late 1980s, the Cold War was winding down, and the collapse of the Soviet Union soon after left the bomber without its primary mission. By 1992, the dissolution of the Strategic Air Command led to the removal of the B-1's nuclear capabilities. From that point onward, the fleet was repurposed exclusively for conventional missions. But the B-1 wasn't destined to fade into irrelevance. The integration of advanced technologies, such as Lockheed Martin's Sniper Advanced Targeting Pod, gave the aircraft a second life. This upgrade allowed the B-1 to deliver precision strikes with modern smart munitions, effectively transforming it into a critical component of 21st century warfare. When the B-1B Lancer bomber made its debut in Operation Desert Fox in Iraq back in 1998, it showcased its effectiveness with what some called a dumb bomb. Despite being a relatively simple weapon, the B-1B's ability to deliver it with remarkable accuracy completely redefined its role on the battlefield. Originally designed as a Cold War-era strategic bomber, it got a fresh lease on life as a versatile close-air support aircraft, proving to be an unexpected hero in the rugged and expansive terrains of Iraq and Syria. The B-1 Lancer has played a critical role in several major military operations, including Operation Allied Force in Kosovo, Operation Enduring Freedom in Afghanistan, and the 2003 invasion of Iraq. Known for its versatility, the B-1 has delivered a wide array of conventional weapons in combat zones, with the 2,000-pound GBU-31 JDAM standing out as one of its most frequently deployed munitions. During the early stages of Operation Enduring Freedom, the B-1 demonstrated its significant contribution to aerial warfare. In just the first 6 months, a fleet of 8 B-1s dropped nearly 40% of all aerial bombs used in the campaign, including an impressive 3,900 JDAMs. These precision-guided munitions were also pivotal in Iraq, where, on April 7, 2003, B-1 bombers participated in a high-profile mission to target Saddam Hussein and his 2 sons, though the attempt was ultimately unsuccessful. The B-1's reliability improved notably during its service in Afghanistan, achieving a mission-capable rate of 79%, a significant milestone given the demanding operational environment. Originally, 100 B-1Bs were built, but by year 2000, 93 remained, with the others lost to accidents. In 2001, the Pentagon proposed placing about 1/3 of the fleet in storage as part of a cost-saving measure. This sparked intense opposition from U.S. Air National Guard officers and members of Congress, leading to the drafting of an amendment to block the cuts. The proposal was aimed at reallocating funds to modernize the remaining aircraft, focusing on upgrades like advanced computer systems to maintain the bomber's cutting-edge capabilities. In 2003, the U.S. Air Force made a strategic decision to retire 33 of its B-1B Lancer bombers, focusing its resources on keeping the rest of the fleet in top operational condition. This move followed the removal of B-1B from the Air National Guard's 2 bomb wings, allowing the military to allocate its budget more efficiently. However, the following year brought a shift in priorities. A new appropriation bill called for some of these retired aircraft to be reactivated. As a result, 7 B-1Bs were pulled out of storage, bringing the fleet back up to 67 aircraft. By July 2007, the B-1B had taken on a vital new role. The Associated Press highlighted the growing USAF presence in Iraq, where the B-1B had been reintroduced as a crucial support platform for coalition ground forces. Its versatility and endurance made it ideal for armed overwatch missions. Starting in 2008, B-1Bs were deployed over Iraq and Afghanistan, circling above combat zones to provide real-time surveillance and immediate air support. Equipped with precision-guided bombs, these bombers could strike enemy targets on demand, significantly boosting ground troops' effectiveness. In addition to combat roles, the B-1B was also at the forefront of aviation innovation. On March 19, 2008, a B-1B from Dyess Air Force Base, Texas, made history by becoming the first USAF aircraft to reach supersonic speeds using a blend of synthetic and petroleum-based fuel. This groundbreaking test, conducted over Texas and New Mexico, was part of a broader initiative to reduce the military's dependence on traditional oil supplies while exploring cleaner, more sustainable energy options. Later that year, on August 4, 2008, a B-1B equipped with the Advanced Sniper Targeting Pod completed its first combat mission. This cutting-edge technology allowed the crew to identify enemy positions with pinpoint accuracy and successfully deploy a GBU-38 guided bomb in Afghanistan. This mission underscored the bomber's evolution into a precision strike platform capable of adapting to modern warfare's demands. The B-1B continued to demonstrate its global reach and versatility. In March 2011, B-1Bs from Ellsworth Air Force Base participated in Operation Odyssey Dawn, striking undisclosed targets in Libya. One of the B-1B standout features is its massive fuel reserves, allowing it to stay airborne for hours on end. This endurance gave it the ability to circle above targets, providing real-time reconnaissance that became crucial for both headquarters and troops engaged in ground operations. The B-1B wasn't just about loitering, though. Equipped with advanced systems like the Sniper Advanced Targeting Pod, it could precisely locate and relay targeting information. Whether guided by data from ground troops or its onboard systems, it could drop thousands of pounds of explosives with pinpoint accuracy, devastating enemy positions, and supporting allied forces in some of the most challenging combat scenarios. Interestingly, the B-1B's potential to carry external weapons was part of its original design during the Cold War. However, due to the Strategic Arms Reduction Treaty, this capability was shelved as part of international disarmament efforts. Fast forward to recent years, this feature has been revived, enabling the aircraft to carry up to a dozen powerful external weapons. This modernized capability enhances its flexibility, ensuring it remains a critical asset in modern warfare. One of the B-1's most notable upgrades is the addition of AGM-158 Joint Air-to-Surface Standoff Missiles and AGM-158C long-range anti-ship missiles. These subsonic cruise missiles are designed to strike from significant distances, allowing the B-1 to neutralize targets with precision while staying out of the range of enemy defenses. The B-1's load-adaptable modular pylon system is a game-changer. It enables the aircraft to carry an impressive total of 36 cruise missiles, 12 on its external pylons, and up to 24 more inside its internal bomb bays. This capacity transforms the B-1 into a powerhouse capable of overwhelming enemy naval forces, particularly in high-stakes scenarios like a conflict in the Asia-Pacific theater, where China's growing naval presence poses a strategic challenge. The B-1 is also gearing up to carry hypersonic weapons, which are currently under active development. Hypersonic missiles, such as the Hypersonic Attack Cruise Missiles, boast remarkable capabilities, including operational ranges of approximately 1,000 miles and mind-boggling speeds of up to Mach 8, 8 times the speed of sound. These missiles are so advanced that they can outpace most existing defense systems, making them nearly impossible to intercept. What makes the B-1 particularly unique is its ability to carry up to 12 hypersonic missiles externally, a feature that significantly boosts its firepower. This combination of advanced cruise and hypersonic missiles positions the B-1 Lancer as a crucial asset in any future military campaign, especially in deterring or countering threats from the People's Republic of China in the increasingly contested waters of the Asia-Pacific region. Originally, this list also included the AGM-138A Air-Launched Rapid Response Weapon, a key component of the Aero Hypersonic Missiles program. However, the U.S. Air Force canceled the development of these hypersonic missiles on March 2023 due to a combination of budget constraints and shifting priorities. Despite the cancellation, the U.S. Air Force still has a remarkable and potent conventional weapon system in its arsenal. If the Air Force manages to equip its remaining 45 B-1 Lancer bombers with the necessary missiles and secure sufficient government funding, it will wield one of the most powerful conventional weapons combinations ever seen. Just 5 B-1 Lancer bombers, crewed by only 15 people, can destroy 6 warships with a combined crew of more than 3,000 sailors. This is an extraordinary efficiency ratio, one that rivals even nuclear weapons in its destructive potential. The B-1 is capable of carrying a wide range of conventional bombs and missiles, including precision-guided munitions, which can be launched from great distances. The B-1's massive payload capacity and ability to fly at high speeds make it a key component of America's airstrike capabilities. And while this kind of power is formidable, it's important to note that even the most advanced aircraft, like the B-1, will eventually need to be replaced. In 2032, the Pentagon plans to begin gradually replacing the B-1 with the cutting-edge B-21 Raider stealth bomber produced by Northrop Grumman. The B-21 is designed with stealth features that allow it to penetrate even the most sophisticated enemy air defense systems. It's intended to be more efficient, cost-effective, and adaptable to future technological needs. Despite this, there's a strong belief among military analysts that the B-1 Lancer could remain relevant far beyond its expected retirement date. With additional upgrades to its avionics, weapon systems, and engine performance, it could continue to perform critical roles in the U.S. Air Force's missions until at least 2040. The B-1's ability to carry 75,000 pounds of bombs and missiles, more than any other U.S. bomber, is one of the reasons it remains so valuable. It can be equipped with a variety of weapons, including Joint Direct Attack munitions, which give it precision strike capabilities, and it can carry out strategic and tactical bombing missions with exceptional effectiveness. Furthermore, despite its age, the B-1 has been continuously upgraded to maintain its relevance in the modern battlefield, with advanced radar, electronic warfare systems, and more. The United States Air Force has always had their technological needs catered for by three of the biggest aerial combat vehicle manufacturers in the country: Northrop Grumman, Boeing, and Lockheed Martin. However, the advent of Elon Musk's SpaceX in 2002 birthed the rise of serious competition in the creation of aerial vehicles. Fast forward to 2025, and SpaceX has reportedly come up with an enticing new bomber plane for the United States Air Force. Could this be the future of bomber jets? Is there a chance that this new cutting-edge bomber sparks a global arms race? Join us as we discuss the brewing bomber between SpaceX and the United States Air Force. Although top high-tech companies like Lockheed Martin, whose Skunk division has played a major role in the creation of some of the United States' greatest combat aerial vehicles, and Northrop Grumman have been at the top end of the pile as the go-to for the America's Department of Defense, the sudden surge of Elon Musk and his SpaceX company has finally brought the heat, the competition needed to give the United States their best. While SpaceX's affiliation with the government might seem sudden, it didn't start that way. It all began with a man who dared to dream, to challenge the old companies like Boeing, who used to champion space travel and the creation of combat and commercial aerial vehicles, while overcoming the high cost of producing rockets, making them reusable and making them safe enough for travel. His name is Elon Musk. Soon he started to get military contracts, earning billions while working with the Pentagon, providing them with a means to launch satellites into orbit. However, the conversation soon moved further than merely launching satellites into the sky, as the Pentagon saw very quickly the potential of Elon's company to create something entirely different from what they used to have, especially since the addition of the behemoth Starship. Now, with Elon's influence in the White House as chief of the Department of Government Efficiency, talks reportedly extended from launching payloads into space for the United States of America to the possible creation of a behemoth bomber that could tower above the United States Air Force bombers like the Boeing B-52 Stratofortress and maybe compete with the Northrop Grumman B-21 Raider. Their rationale was rather simple. Elon is already on the cusp of creating aerial vehicles fast enough to hit Mars by 2026, so why wait for relatively slow bombers which travel at subsonic speed when there is a possibility of Elon creating something faster and relatively more lethal? Although SpaceX has never developed a weaponized combat aerial aircraft, being at the adult table at the Pentagon comes with making tough choices and new decisions, something rather different from a favorite niche. Hence, he reportedly agreed, and SpaceX now stands on the precipice, holding the fate of the United States bomber jets in his palms. Although Elon is a genius, what does he know of warfare to be completely entrusted with creating a bomber for the United States? And how does it supposedly compare to his predecessors, especially the B-52 Stratofortress? However, to understand the gravity of Musk's task, we need to look at his competition, the B-52 Stratofortress bomber. The B-52 Stratofortress bomber is a titan of the Cold War, a behemoth that shows up, and the opposition already knows that it is not going to be a good day. As often reported, Boeing really outdid itself on the Boeing B-52 Stratofortress, as it shattered every conventional assumption and belief about the limitations of bombers in the 1950s. The Boeing B-52 Stratofortress is a long-range, subsonic, jet-powered strategic bomber, meaning that it could hit the target not only from seriously ridiculous heights, but it could also have debilitating effects on the opposition, and they would suddenly break their spirits enough to avoid a full-blown or all-out war. For some context, Operation Linebacker 2 in 1972 saw the use of the B-52 Stratofortress bomber in strategic warfare in an attempt to reach a quick ceasefire. The operation took place during the Vietnam War, when the United States unleashed the full strength of its air forces, with the B-52 Stratofortress bomber at the very centerpiece. The operation lasted from the 18th of December to the 29th of December, 1972, during the North Vietnamese War. They unleashed more than 20,000 ordnance that was dropped on military and industrial areas in Hanoi and Haiphong, and at least 1,624 civilians were killed. The operation was the final major military operation carried out by the United States during the conflict and the largest bombing campaign involving heavy bombers since World War II, and Vietnam just didn't know what hit them. After the rain of fire from the bomber, their spirits were broken, so they threw in the towel and decided against an all-out as they stood no chance against a bomber. But what makes the B-52 bomber special, and how was it brought into being in the first place? Let's dial back to November 23, 1945, when the AMC, otherwise called the Air Materiel Command, issued desired performance characteristics for a new strategic bomber that could be used as a long-range bomber without needing a base on foreign grounds, which may be controlled by other countries. They wanted the aircraft to travel at least 34,000 feet, with a crew of 5 or more working the gun turret and a 6-man team that will be working as a relief crew. However, as is popular with a combat aerial vehicle, the ordnances and bombs it carries as payload are of grave importance. What's the point of a bomber jet without enough payload to send anyone running? So they asked for an unspecified number of 20mm cannons and over 4,500 kilograms of bombs. The United States Air Force immediately sent out a bid invitation, inviting all the heavyweights of America's aircraft companies, including Boeing, Consolidated Aircraft, and Glenn L. Martin, to submit proposals. Eventually, Boeing won the 3-horse race and called and got a massive $1.7 million to build a full-scale mock-up of the XB-52 and do preliminary engineering and testing. However, they had trouble at first meeting the specification until much later, when they finally created the B-52 version, with the perfect size and ability to take on payloads. B-52 Stratofortress was designed to have swept wings, potted jet engines, and also crew ejection systems in case of a crash, or if it ever happens that they encounter anti-aircraft resistance strong enough to shoot down the aircraft. However, there are different versions of the B-52 with a little bit of difference in their structural designs. For example, on the B-52D, the pilots in the electronic countermeasure team are ejected upwards, while the crew on the lower deck are ejected downwards. However, the tail gunner, who was stationed at the rear end of the bomber jet, had to manually jettison the gun turret before they then crawled out through the opening, making the survivability percentage extremely low. Enter the B-52G, which was released August 31, 1958, as a potential successor to the B-52D. The G version was stronger and better, and the survivability percentage for whoever manned the gun turret was increased by well over 60%, as they could now eject like everyone else. Although the survivability of the crew has been protected by the changes made to the placement of the gun turret, the aircraft still had a common problem: structural fatigue. In material science, fatigue is the initiation and propagation of cracks in a material due to cyclic loading. Once a fatigue crack has initiated, it grows a small amount with each loading cycle, typically producing striations on some parts of the fracture surface. In the aircraft, the fatigue was accelerated by low flying, 8 times more than it was affected when it was flown higher in the sky. For some context, flying really high in the sky is much easier, as there are fewer needs for sharp turns or a need to zoom faster. However, when they fly too close to the ground, there is a need to turn sharper, focus on maneuvering around rocks, and really work the body of the bomber jet. The metal starts to get tired, it cracks, and in some rare cases it bends almost out of shape, requiring the need to fix the plane. The classic wear and tear was starting to make the bomber jets difficult to use for more than 2,000 hours of flight. So in the early 1960s, The United States Air Force created the high-stress program as some sort of checkup program for every B-52 bomber that had been in the sky for over 2,000 hours and was surely going through some structural fatigue. Once they look through the B-52s that had flown over 2,000 hours, they check which one needs to be fixed, and they have stronger pieces added to the body of the bomber, giving it a bit more leverage to fly for that long. As time went on, the Air Force got even craftier, with the creation of wet wings attached to their G and H models of the B-52s. They were called wet wings because they were capable of holding way more fuel than the other models. However, that compromised the structural integrity of the bomber jet even further. The added weight on the wings from the fuel forced the wings to bend out of shape, and they got 60% more fatigue than the B-52D. Once again, the need arose for a solution, so they created the ECP-1050 as a replacement for the wet wings, which increased the durability of the jets and reduced the percentage of quick wear and tear. But there was something more about the bomber, as its sheer size meant that it couldn't perform huge spins or a loop-de-loop like a fighter jet could at an aviation show or in combat. Although the yaw, pitch, and roll were added parts to the bomber plane, it was not built to move like a stunt plane. Instead, the flight controls were focused on vertical stability, even though it has a relatively small, narrow chord rudder, giving it limited yaw control authority. It was almost like having a giant school bus in the air, big, powerful, and with enough room to carry people and ordnances. However, by 1977, they conducted a pacer plank reskinning. The structural fatigue while moving at Mach 1 speed, which is subsonic, was a message to the United States Air Force to make a change. But the United States Air Force continued instead to rely on the jet for its services during war, especially because of its armament as a bomber plane, which is much better than its predecessors. The bomber plan was optimized to carry up to 20 Boeing AGM-69 SRAM nuclear missiles, which are air-to-surface missiles with a nuclear warhead. It had a range of up to 110 nautical miles and was intended to allow United States Air Force strategic bombers to penetrate Soviet airspace by neutralizing surface-to-air missile defenses. It was the perfect response to surface-to-air missiles because it was easier to direct, owing to its precision systems. In a bid to further improve its offensive ability, air-launched cruise missiles, or ALCMs in popular military parlance, were fitted into the B-52 bomber jet. However, after testing of both weapons of mass destruction, the United States Air Force-backed Boeing AGM-86 air-launched cruise missile and the Navy-backed General Dynamics AGM-109 Tomahawk, the AGM-86B was selected for operation by the B-52. However, the continuous development of more models of the B-52 Stratofortress, the Conventional Enhancement Modification, or CEM program, gave the B-52H a more comprehensive conventional weapons capability, adding the modified underwing weapon pylons used by conventional armed B-52Gs, Harpoon and Have-Nap, and the capability to carry new generation weapons including the Joint Direct Attack Munition, or JDAM, and Wind-Corrected Munitions Dispenser guided bombs, the AGM-154, glide bomb, and the AGM-158 JASSM missile. While the B-52 remains a legendary bomber, the times have changed and technology is moving on once again. Although the B-52 bomber remains in use by the United States Air Force when needed, the Northrop Grumman B-21 Raider has come to take its place in the United States Air Force, and the world's about to be introduced to it. But what makes the Northrop Grumman B-21 Raider special enough to become a welcome addition to the new Air Force fleet? The Northrop Grumman B-21 Raider is another masterclass strategic bomber plane being developed in the United States. It is being developed at the behest of the United States Air Force as a part of the Long Range Strike Bomber, or LRSB program, but this time it is a complete upgrade on what the B-52 Stratofortress was capable of. Imagine a bomber jet capable of stealth operations and the ability to deliver conventional and thermonuclear weapons. Well, with the Northrop Grumman B-21 Raider, no one has to imagine anymore. The classified program started in 2011 when the United States Air Force decided it needed a faster bomber plane with more range. So, as is usual practice, they reached out to the heavyweights in the game, offering them a development contract which was eventually awarded to Northrop Grumman in October 2015. Of course, every company wanted to be in charge of the future of the Air Force fleet, but someone had to win. This time, it was Northrop Grumman. However, a civil war ensued, with Boeing and Lockheed Martin, who submitted losing bids for the project, filing bid protests, claiming they had been wrongfully overlooked for Northrop Grumman. In October 2016, the Government Accountability Office, or GAO, rejected the challenges and sustained the United States Air Force's decision to award the LRS-B contract to Northrop Grumman. The Government Accountability Office report revealed that cost was the deciding factor in selecting Northrop Grumman over the Boeing-Lockheed Martin team. The Air Force set up an uphill task for Northrop Grumman, telling them that they needed an addition of intelligence gathering, battle management, and interceptor features to the bomber, and a fifth-generation global precision system that guides the release of bombs, nuclear warheads, and all types of payloads it might be carrying. However, alongside India, which is on the cusp of unleashing its sixth-generation aircraft, albeit a fighter jet, the United States is closing in on releasing the first-ever sixth-generation aircraft, but this time, a bomber jet. Fast forward 5 years after it was commissioned to Northrop Grumman, and the Air Force released new renderings of the aircraft, showing a smaller and lighter design than what is typically expected from a bomber. The sheer reduction in size and distinctive flush in blended inlets, with the two-wheel landing gear design, was a revelation of something never seen before. The drawing shows a smaller and much lighter aircraft than its predecessors, like the B-2 and the massive subsonic B-52 Stratofortress. The world had finally had a glimpse at the possibility of the future of bomber planes, with the huge reduction in size being a topic for discussion. However, just a year later, Darlene Costello, the acting Assistant Secretary of the Air Force Acquisition, Technology and Logistics, confirmed that the first two B-21s were under construction at Plant 42. D-Day came on December 2, 2022, when the first-ever B-21 was unveiled at the Northrop Grumman production facilities in Palmdale, California. At the unveiling, Northrop CEO Kathy Warden said that the B-21 is designed with modular, open systems architecture to allow easy upgrades and, potentially, the ability to export components to foreign buyers. The open systems architecture wasn't particularly the most popular form of building jets in the past, especially when a Cold War hero like the B-52 Stratofortress was built. Boeing at the time had relied heavily on the importance of closed architecture systems, which made fixing and upgrading the early B-52s a nightmare for mechanical engineers, who had the pleasure. The open systems architecture is more like building up a Lego character, and all that needs to be done for a quick fix or an upgrade is to simply remove and replace without a need to tear apart the whole structure in the name of rebuilding. On the flip side, the closed structure system is a packed and sealed deal. A fix would need a complete deconstruction of the object before being rearranged, regardless of how massive or small the problem is. Although the popular reasoning is to view the very first tested aircraft as a prototype, the test aircraft was not deemed as one. Rather, it will be converted to operational configuration by the Air Force after the test flight has been completed. In 2023, the officials of the Long-Range Bomber Program revealed that the fueling and engine tests took place at the end of the year and were successful, leading to the approval of a low-rate initial production, or LRIP, contract being awarded to Northrop Grumman in January 2024, meaning that there would be a small batch of B-21 Raiders in the production phase and about to be released in 2025. However, new speculations about Elon Musk, the Tesla and SpaceX boss, creating a behemoth bomber of his own, sanctioned privately by the Pentagon, seem not to be going away. A shocking tale despite the news of the imminent release of the B-21. Although the mystery remains nail-biting and fairly disturbing, as there are no signs of signed documents or public articles that are published to that effect, the speculations remain intact, with specifications of a possible sixth-generation SpaceX bomber capable of a direct lift off the ground and possibly carrier-based, and also due to be released the same time as the B-21 Raiders. Whether Elon Musk's clandestine arrangement to release a SpaceX bomber in 2025 is real or other media noise, only time will tell. The legendary B-2 Spirit stealth bomber has returned with groundbreaking upgrades that push the limits of military technology. Once a Cold War secret, it's now been transformed into a weapon that feels decades ahead of its time. From hypersonic readiness to futuristic invisibility, this aircraft has left rival nations scrambling to catch up. Why are experts calling it the most advanced bomber in history? And what does its rebirth mean for the future of global defense? Join us as we uncover the secrets behind the upgraded B-2 Spirit. The B-2 Spirit stealth bomber has just received a round of upgrades that defense analysts describe as almost unbelievable for an aircraft that first flew more than 3 decades ago. What was once a Cold War marvel has now been reshaped into something that feels designed for the next generation of warfare. At the heart of this modernization effort is a system called Spirit Realm 1, or SR1. With this open mission system setup, the bomber can take on new weapons and functions through simple software updates instead of requiring costly hardware changes. Thanks to this framework, the Air Force can integrate advanced munitions, such as the GBU-72 bunker buster, and may even prepare the platform to carry hypersonic missiles, all without dismantling the aircraft. Engineers took a very different approach with this upgrade. By adopting what they refer to as a software factory model, teams are now able to design, test, and roll out new features at a speed that would have been unimaginable in the past. This method reduces defects, speeds up development, and ensures that the new features work seamlessly alongside the B-2's existing avionics. The cockpit has been updated as well. Pilots now work with improved displays that provide real-time battlefield information, helping them plan missions more efficiently and react faster while in the air. Communication systems have been modernized as well, replacing the old single-channel setup with a system that supports simultaneous voice and data transmission. One of the most critical improvements came from advances in satellite communications. Through beyond line-of-sight connectivity, crews are now able to get real-time updates on targets and shifting mission requirements, even when operating deep inside contested airspace. This level of in-flight adaptability greatly improves overall mission flexibility. At the same time, stealth remains the B-2's defining advantage, and engineers have continued working to make it even more effective. A specialized survivability team has introduced both hardware and software enhancements to sharpen the bomber's radar cross-section signature. These tools give pilots the ability to detect, locate, and classify enemy air defense systems while still preserving their low-visibility profile. This round of changes builds on earlier efforts under the Defensive Management System Modernization Program, which upgraded the aircraft's electronic warfare suite. The B-2 can now detect and classify threats while also gathering valuable electronic intelligence, all while remaining cloaked from radar. The timing of these developments is no accident. Both Russia and China have spent years designing advanced radar networks and missile systems specifically aimed at countering stealth technology. Keeping the B-2 ahead of those capabilities is vital, especially since the aircraft continues to serve as America's only long-range penetrating strike bomber. Today, just 19 B-2s remain in service after the loss of 2 aircraft in earlier incidents. Each one undergoes a full overhaul roughly every 9 years, which includes structural maintenance and the reapplication of radar-absorbing coatings. Because the fleet is so small, extending the life and relevance of each aircraft is considered essential for maintaining the United States' ability to strike targets anywhere in the world. The B-2 can deliver up to 40,000 pounds of conventional or nuclear weapons and, with aerial refueling, can reach intercontinental targets without detection. Until the new B-21 Raider enters service later this decade, the Spirit remains the backbone of America's deep strike capability. The Spirit Realm 1 program makes sure the bomber doesn't fall behind. By relying on continuous software upgrades rather than major redesigns, the Air Force can keep the B-2 responsive to evolving technologies and threats. Defense officials believe these changes will keep the bomber viable well into the 20s. The flying wing design that once looked decades ahead of its time has now been adapted again, proving that a concept born in the 1980s can still set the standard for next-generation aviation. The most expensive military aircraft ever built has now advanced to a point where it seems to defy the very rules of radar detection. How can a machine larger than half a football field disappear from the most sophisticated surveillance systems in the world? The B-2 Spirit achieves a kind of invisibility that once seemed impossible. Radar operators facing the aircraft often find their screens showing nothing but empty sky. Despite being 69 feet long with a wingspan of 100 to 72 feet, the bomber can appear no larger than a small bird on advanced detection equipment. The foundation of this ability lies in its design. Unlike older bombers that rely on vertical fins and sharp edges, the B-2 was designed as a seamless flying wing. The design of the aircraft forces radar signals to scatter in multiple directions instead of bouncing straight back to enemy stations, which makes the bomber much harder to track. Equally important is the special coating that covers the entire surface. This material absorbs those signals and disperses the energy as heat rather than sending it back to detection systems. Maintaining that protective layer is a constant challenge. Each bomber must be kept in climate-controlled hangars, and about every 9 years, the aircraft goes through a major depot cycle where technicians carefully strip and reapply the coating to preserve its stealth. The process costs millions of dollars per aircraft, but without it, the B-2 would quickly lose the low visibility that makes it so valuable. Even the engines were designed with stealth in mind. 4 General Electric F118 engines sit hidden within the wing itself. The air intakes use curved ducts that block radar waves from reaching the turbine blades, which would otherwise light up on detection systems. Exhaust nozzles mix hot gases with cooler outside air to cut down on heat emissions, lowering the aircraft's infrared signature. Heat-absorbing tiles, similar to those once used on the space shuttle, line critical areas of the bomber. These prevent heat tracking systems from locking onto the B-2 even when it operates at altitudes above 50,000 feet. Another remarkable feature is its contrail management system. Most high-altitude aircraft leave long vapor trails that give away their position. The B-2 can suppress contrail formation when necessary, erasing this common giveaway during sensitive missions. Stealth systems come together through what pilots call penetration mode, activated by a button marked PEN. Once engaged, this mode synchronizes all of the bomber's stealth technologies to minimize signatures across radar, infrared, and visual detection. Enemy radar crews often report nothing more than background noise when the B-2 is in this state. The idea of a flying wing is not new. Jack Northrop tested the concept with his YB-49 prototype back in 1947, which had the same wingspan as the modern B-2. Even Germany experimented with a similar design during World War II, building the Horten-Ho 229, but their version lacked the advanced materials and precision engineering that would make the American design truly practical. The science behind the B-2's stealth owes much to Soviet research. In 1962, Russian physicist Pyotr Ufimtsev released groundbreaking research on the way electromagnetic waves interact with different surfaces. His work was meant as pure science, but American engineers later applied those principles to develop the B-2's unique radar-deflecting shape. What began as a theory in a textbook eventually became the foundation for an aircraft designed to slip past Soviet air defenses. The result was the B-2 Spirit, a bomber that blends geometry, radar-absorbing coatings, hidden engines, and thermal management into a single design. Together, these features make it extraordinarily difficult to detect with conventional tracking methods. For air defense crews, the reality is simple. It is nearly impossible to shoot down something you cannot see, hear, or lock onto. Even with all the advanced stealth technology built into the B-2, the aircraft itself is useless without the right person in the cockpit. But what exactly makes someone qualified to fly America's most secret bomber? Since the B-2 Spirit program began, fewer than 300 pilots have ever been trusted to fly it. That number is shockingly small when you consider the size of the United States Air Force. It is often described as the most selective flying group in military history, with acceptance rates so low that even the Navy SEALs seem easier to get into. Getting selected is about much more than raw flying skills. Each candidate goes through psychological testing that digs far deeper than the usual pilot requirements. Military doctors look at personality traits, stress tolerance, and even how well someone can get along with others. Missions can last close to 2 full days, with 2 people locked inside a tight cockpit. The Air Force cannot risk putting 2 pilots together if there's even a chance they might clash or buckle under pressure. Physical skill is just as important. B-2 pilots must have excellent reflexes and steady hands, especially for tasks like refueling in the air, which requires near-perfect precision. The B-2 doesn't fly like any other plane. It has unusual flying wing aerodynamics that demand special handling skills. Learning to control it means starting almost from scratch, even for experienced pilots. On top of that, the security checks are among the strictest in the military. Candidates face background investigations that cover their personal history, family ties, and even their finances. The government wants to be sure that no one flying the B-2 could be blackmailed or bribed into betraying sensitive secrets. Training is another hurdle. Before touching the actual bomber, pilots spend months inside advanced simulators that recreate every system, warning light, and emergency the plane might face. Instructors throw constant challenges at them: engine failures, electrical problems, combat situations, and even extreme weather. Only those who make quick, smart decisions under stress can move forward. Mission commanders receive extra instruction beyond just flying. They are trained in weapons use, navigation, and electronic countermeasures that protect the bomber from enemy defenses. While the pilot focuses on flying, the commander handles the systems. Success depends on both working seamlessly as a team during missions that can stretch almost 2 days without landing. The B-2's cockpit is designed differently from most military aircraft. Instead of sitting one behind the other, both crew members sit side by side in ejection seats. This makes long flights easier to manage because communication is more natural. However, it also forces pilots to adapt to a wider forward view that feels very different compared to other planes. All B-2 flights operate out of one location, Whiteman Air Force Base in Missouri. The base has specially built hangars that control temperature and humidity to protect the bomber's delicate stealth coating. Pilots often spend weeks at a time training or preparing for missions, which means long stretches away from family. Interestingly, most B-2 pilots only fly a handful of missions each year. The bomber fleet is small, and each aircraft is unique. To stay sharp, pilots rotate between different planes so they remain familiar with how each one handles. For many, flying the B-2 represents the peak of their career. Once they retire from the program, they often don't move on to fly other aircraft because of how specialized the training is. Instead, some stay connected to the bomber community by working as instructors or taking contractor roles that support the program. The limited number of trained pilots poses challenges for the Air Force. Whenever the bombers are needed, commanders must carefully balance mission schedules, rest time, and training requirements. Each pilot represents years of investment and cannot be replaced quickly. It is this scarcity, along with the difficulty of the training, that makes the B-2 community one of the most exclusive groups in the entire United States military. These top pilots showed their true skill in missions that are still studied by military experts today. But here's the question: how could just 2 bombers completely change the way wars are fought from the sky? The B-2 bomber made its combat debut over Kosovo in 1999, and it instantly rewrote the rules of air warfare. 2 bombers flew missions that lasted 31 hours straight, leaving from Whiteman Air Force Base in Missouri, striking their targets in the Balkans, and flying back without stopping anywhere in between. Even though the B-2 made up less than 1% of all combat flights during Operation Allied Force, it destroyed nearly 1/3 of the priority targets in just the first 8 weeks of the conflict. Military leaders had never seen anything like this. Normally, hundreds of planes and multiple waves of attacks were needed to get the same results. The B-2 managed to do in one mission what entire groups of aircraft struggled to accomplish. The bomber named Spirit of America set a record during Operation Enduring Freedom in 2001. It flew the longest combat mission in history, 44 hours non-stop from Missouri to Afghanistan and back. The engines never even shut down during a quick 45-minute crew change, after which the aircraft immediately launched again for another 30-hour flight. In total, it stayed in continuous operation for more than 70 hours. Each B-2 carried up to 40,000 pounds of guided bombs and smart weapons on these missions. These weapons were so accurate that commanders on the ground reported that the B-2 was able to hit high-value targets that other aircraft couldn't touch. Because the missions were so long, refueling in the air was essential. Every 6 hours or so, a KC-135 tanker would meet the bomber high above enemy territory to transfer fuel. Both aircraft had to fly in perfect sync for the transfer to work, making it one of the most delicate parts of the mission. The B-2 quickly became the aircraft trusted to strike first. It opened operations in Iraq, Afghanistan, and Libya by slipping into heavily defended airspace that other aircraft couldn't enter safely. Once the B-2 had destroyed key defenses, other planes could follow. Today, this first strike role is standard military practice. What made the B-2 so valuable was its ability to hit any target in the world within hours of being ordered. It didn't need bases in other countries or staging areas closer to the fight. It could launch straight from the United States and still complete its mission. Its advanced navigation systems meant it could fly and strike accurately in any conditions. Using radar and GPS-guided bombs, it could hit through thick clouds, heavy storms, or complete darkness. Enemies learned that bad weather could no longer protect them. Each mission proved that the billions spent on stealth technology and long-range strike power had been worth it. The B-2 showed it could achieve major objectives while putting very few aircrew at risk and with minimal civilian casualties. Planning these missions was just as demanding as the flights themselves. Crews spent hours studying maps, enemy defenses, weather, and backup targets before even stepping into the cockpit. Sometimes the planning lasted longer than the actual flight. After the missions, reviews showed the same results again and again. The B-2 hit its targets more effectively than traditional bombing campaigns, while needing far fewer aircraft and weapons to do the job. Despite its remarkable record in combat, America's most advanced bomber faces a serious challenge that could weaken national security. The question is simple but troubling. Why are these rare aircraft disappearing one after another? Back in the Cold War years, the United States planned to build 132 B-2 Spirit bombers. Defense companies prepared for huge orders, expecting that the cost per aircraft would drop once production ramped up. The goal was to create a fleet big enough to eventually take the place of the older B-52 bombers. But history shifted. In 1989, the same year the B-2 took its first flight, the Berlin Wall fell. The Soviet Union collapsed soon after, and with it the need for such a large stealth bomber force. Congress slashed the order from over 100 to just 21 planes. That decision made each B-2 incredibly expensive, more than $2 billion apiece. With so few built, every aircraft became almost like a custom project, each with its quirks and demanding upkeep. Since entering service, the fleet has lost 2 bombers. In 2008, the Spirit of Kansas crashed during takeoff in Guam after faulty sensors caused it to lift its nose too sharply. The crew ejected safely, but the aircraft was destroyed, just like that. America lost 4% of its stealth strike power. Another bomber, the Spirit of Washington, caught fire during maintenance at Whiteman Air Force Base in 2010. Workers accidentally set off a blaze that damaged the bomber's delicate structure and stealth coating. The Air Force debated for years whether fixing it was even possible before finally bringing it back to service. In 2022, another B-2 was badly damaged in a fire and written off completely. That incident left only 19 operational bombers, each one now an irreplaceable part of America's long-range strike force. To keep them flying, every B-2 goes through a deep overhaul about once every 9 years. This isn't routine maintenance, it's a complete rebuild. Workers strip off and reapply the radar-absorbing coating, upgrade the electronics, and replace or repair major systems. Each cycle costs hundreds of millions of dollars and takes months before the plane can return to duty. The aircraft are stored in special climate-controlled hangars at Whiteman Air Force Base in Missouri. The stealth coating is so sensitive that both temperature and humidity must stay within strict limits. If exposed to bad weather or stored incorrectly, the coating can break down, making the bomber easier to spot on radar. Building the B-2 in the first place meant inventing new ways of making things. Northrop Grumman developed advanced composite materials, custom tools, and entirely new assembly techniques just for this program. Once the final bomber rolled out, those production lines were shut down. That means no more B-2s can ever be built with the same methods. Looking ahead, the Air Force plans to keep the B-2 in service until the new B-21 Raider is ready in larger numbers. The Raider is designed with modern materials and updated production techniques, and it also draws on lessons learned from the B-2 program. The first B-21 bombers are expected to be combat-ready later in the decade. For now, though, the B-2 remains the only aircraft that can slip past the world's toughest air defenses and strike anywhere on the globe. Losing even one more reduces America's reach and weakens its ability to respond to threats far from home. After the Second World War, Japan became very cautious about rebuilding its military, especially its air force, which now appears outdated compared to that of other countries. The memories of Hiroshima and Nagasaki still remind everyone of how terrible war can be. Japan's new constitution, drafted with the help of the United States after the war, took a firm stand against war. In Article 9, Japan relinquished its right to wage war or maintain military forces for aggression, limiting its forces to self-defense purposes only. Japan also made a deal with the United States for protection. American troops, including air forces, stayed in Japan to defend the country. This allowed Japan to rebuild its cities, businesses, and industries without undue concern for war. But as time went on, growing problems with China and fears about North Korea's missiles made Japan change its thinking. China's rapid rise in both economic and military strength began to appear more unfriendly toward Japan. Because Japan supported Taiwan and worked closely with the United States, China hit back with trade bans and boycotts. Behind the scenes, China also used cyber attacks and spying. They broke into Japan's government and business systems, attempting to steal sensitive secrets related to defense and technology. China sent more ships and planes close to Japan's borders. They started doing regular live-fire drills and even launched ballistic missiles near Taiwan, one of Japan's close partners. With danger rising, Japan recognized the need to enhance its air force, rather than relying solely on others, especially since China and Russia are now introducing more advanced fighter jets. In a big move, Japan's leaders have recently agreed on new rules that would enable the country to respond more effectively to threats. Former Prime Minister Fumio Kishida stated that, with missiles becoming faster and more deadly around the world, Japan must strengthen its defense to deter future attacks. This decision also followed the United States urging of Japan to assume a greater role in containing China's expanding military. This new plan will increase its defense budget to 2% of its economy by 2027, doubling the amount it currently spends. With more money, Japan will buy advanced weapons from the United States like Tomahawk missiles and work on building its top-level fighter jets, super-fast missiles, and armed drones. Initially, Japan sought to acquire the Lockheed Martin F-22 Raptor. However, the United States refused to sell the jet to any other country, thereby keeping its technology safe and leaving Japan at a disadvantage. So Japan made a bold choice to design and build its sixth-generation fighter jet. It's a challenging project, but if they succeed, Japan could end up producing one of the world's best warplanes and become a major player in the arms market. Between 2009 and 2010, Japan's Ministry of Defense took a deep look into fighter jet technology. From this work came the idea of the I-3 fighter, which stands for Informed, Intelligent, and Instantaneous. This jet was designed to be a stealth fighter capable of detecting and engaging other stealthy planes. It would come equipped with a powerful radar system, smart sensors, and the capability to communicate with external drones and sensor stations during battles. All these features were meant to give Japan a big advantage in controlling the skies around its region. The I-3 fighter could also carry new types of weapons, such as laser guns, known as light-speed weapons, that could instantly destroy incoming threats. As expected, China responded to Japan's plan with harsh words, accusing Japan of fabricating the China threat as a pretext for building more weapons. However, Japan is pushing forward, determined to rely more on itself and defend its territory. To turn their ideas into reality, Japan created a test plane called the Mitsubishi X-2 Shinshin. The X-2 was designed with a look similar to that of modern fifth-generation fighters, such as the Lockheed F-22 Raptor. Its size was comparable to that of the Swedish Saab JAS 39 Gripen. Measuring approximately 14 meters in length with a wingspan of 9 meters, it weighed almost 13 tons and was equipped with strong turbojet engines featuring 3D thrust control, which provided it with remarkable agility and the ability to fly at supersonic speeds. One of the most notable features of the X-2 was its fly-by-optics system. Instead of using traditional cables, it utilizes optical fibers, which enable faster data sharing and better noise handling. Its radar, called the multifunction RF sensor, was built with an active electronically scanned array, known as AESA technology, allowing it to switch across different signals for jamming, communication, and possibly even using microwave weapons. Another notable feature was its self-repairing flight control system. If the plane's flight surfaces got damaged, it could detect the problem and adjust by using the parts that still worked, keeping the jet flying safely. For its test flights, the X-2 used two XF-5 engines. The work was led by Japan's Acquisition Technology and Logistics Agency. They made a small demo plane called the Advanced Technology Demonstrator, or ATDX for short, which flew 34 missions in 2016 and 2017. ATLA also ran 14 other programs focused on building the key components needed for a real stealth fighter, such as improved sensors, faster data links, and concealed weapon bays. The prototype was a big success. Many of the new systems tested on it will likely be used in Japan's future sixth-generation fighter jet. The twin-engine plane had a sleek and smooth shape, standing about 4.51 meters tall. Its cropped delta wings and special extensions allowed it to keep flying safely even at high angles. Two vertical fins at the rear helped improve both its flight capabilities and stealth. It was piloted by a single pilot and featured a retractable tricycle landing gear setup, smooth control surfaces, and two rectangular air intakes positioned adjacent to the cockpit. The special S-duct design also made its airflow smoother and more conducive to speed. After the success of the X-2 project, Japan's Ministry of Defense started working on the Mitsubishi FX in 2020. This new twin-engine stealth fighter is designed for air battles and is planned to be even larger than the F-22, which has earned it the nickname Godzilla. Its large size would give it a longer flight range and the ability to carry a greater number of weapons. It is also designed to have a robust network system and carry more missiles than the F-35. Engineers experimented with various exterior designs using 3D models and specialized computer programs. The primary goals were to make it extremely fast, highly agile, and exceptionally stealthy. To make it lighter and more flexible, the FX would ditch hydraulic systems and utilize electronic components instead. It would also use strong glue molds instead of regular bolts and screws. Two XF-9 engines would power the plane, providing it with more than 20 tons of thrust. These engines would have special 3D thrust nozzles to help them turn more quickly and remain hidden. For its weapons and defense, the FX would feature an advanced mix of sensors to track and engage stealthy enemy planes. It would carry an active electronically scanned radar, a passive radio wave sensor, and an infrared camera. All of these would utilize gallium nitride technology to better detect targets that are normally difficult to see. The new jet would also feature a sophisticated radio system that could jam enemy signals worldwide, enabling it to intercept and counter incoming missiles. Pilots would receive a high-tech helmet equipped with a wide field of view, dual-eye displays, colorful screens, voice control, and 3D sound. The FX's stealth features would include twisted air ducts, hidden weapon bays, materials that absorb radar waves, and new metamaterials to make it even harder to detect. A plasma stealth system would generate short plasma bursts to deflect radar waves, thereby further protecting the plane. Beyond conventional armaments, the FX will be armed with a microwave cannon to disrupt incoming missiles. It will also have the ability to deploy combat support unmanned aircraft drones, serving as loyal wingmen to the fighter. These drones will aid in target identification, munition deployment, and the deflection of incoming missiles. If the FX Godzilla lives up to even a fraction of its potential, it could provide the Japanese armed forces with a formidable warplane surpassing anything in today's skies. Furthermore, it has the potential to propel Japan into the global weapons development market, solidifying its position as a military manufacturing powerhouse. Another important job for the FX Godzilla is to replace Japan's current F-2 fighter jets during the 2030s. It's clear that Japan also draws some ideas from the US regarding the FX's design and functionality. Japan even bought some F-35s to use alongside the FX once it is ready. In 2022, rumors started flying that Japan and the UK might join forces by merging Japan's FX project with the UK's Tempest fighter program. By December 2022, the partnership was officially announced, and Italy joined the team as well. Initially, the UK sought to collaborate with France and Germany through a program called the Future Combat Air System. However, after numerous arguments and delays, the UK ultimately decided to collaborate with Japan and Italy instead. This new collaboration is a significant win for both parties. Japan secures strong partners who can help it sell military planes overseas, an area where it lacks substantial experience and expertise. The UK gets serious partners without the problems it faced before. Together, they aim to develop a powerful sixth-generation stealth fighter that could revolutionize the future of air combat. Big companies were given key tasks. Mitsubishi Heavy Industries from Japan and BAE Systems from the UK are leading the project. BAE is also working on the main body of the jet. Japan's IHI Corporation and Rolls-Royce are building the engines. Italy's Leonardo is responsible for the electronics, while MBDA UK handles the missile systems. After Japan and Britain teamed up, they also began working together on radar systems through a project called Jaguar, an acronym for Japan and Great Britain's Universal Advanced Radar Frequency System. The new fighter will be about 30% bigger than the Eurofighter Typhoon. Its weight without fuel will be close to that of the American F-15 Eagle. The plane will have a sharp delta wing with a 50-degree sweep. The wingspan will be around 54 feet, and the total wing area will be about 12,200 square feet, almost the same as the wing size of an Airbus A320. A model of the new fighter was first shown at the Farnborough Air Show in 2024. It features a trimmed delta wing, which enables it to fly faster, travel farther, and carry more weapons and fuel. However, it may not be as adept at quick turns and sharp maneuvers as Japan's original FX design. British aviation journalist Gareth Jennings pointed out that the GSAP's broad wings look a lot like those of the old American F-111 Aardvark bomber. The F-111 used to fly low to stay hidden from radar, but the GSAP will mainly depend on stealth and long-range missiles to remain safe. This plan is similar to the FB-22, a bomber version of the F-22 Raptor that never entered service. Unlike the FB-22, which was built solely for support, the GCAP is designed to engage other planes and strike ground targets. All three countries working on the GSAP already use F-35B stealth fighters, except the UK, which also flies the F-35A. However, they still sought a jet that could carry more weapons than the F-35 and could be sold to other countries without the stringent restrictions associated with the American F-22 Raptor. Japan also plans to fit the GSAP with its high-tech missile systems. These will include the MBDA Meteor, the Spear 3, and the ASM-3, which is a Japanese anti-ship missile. Japan and Britain are also collaborating to develop a new medium-range air-to-air missile, known as the Joint New Air-to-Air Missile. Rumor has it that the JN-8M will feature a radar system manufactured by Japan at the front and a Meteor ramjet engine from Britain at the rear. Still, it may be slower than the Meteor, which can travel at over Mach 4. The JN-8M's top speed is expected to be around Mach 3.5. As for the schedule, the first flight of a Tempest concept demonstrator, a prototype built to test new technology, is planned for 2027. According to the UK Ministry of Defence's Director for Future Combat Air, this test plane will give a strong idea of what the final GEAP fighter will look like. Work on the joint engine demonstrator began in 2024, with the UK investing an initial £30 million in planning, digital design, and innovative construction methods. An additional £200 million from the UK will be allocated toward building a full-size engine for testing. This work will also create many skilled jobs, including at Rolls-Royce's Filton site in Bristol. The first flight of the Tempest is expected to happen in 2035. It will eventually replace the Eurofighter Typhoon in Italy and the UK, as well as the Saab Gripen in Sweden. During its production, they plan to use 3D printing to make parts. Leonardo is also building a new type of radar system for the Tempest. Instead of using a single large radar, this new system will utilize numerous small antennas and mini receivers to collect vast amounts of information from both the sky and the ground. Like other sixth-generation jets, the Tempest is likely to utilize artificial intelligence to control drones, building upon the concept of the loyal wingman. The cockpit will feature augmented reality, making the plane even more advanced. Fast progress and teamwork between countries will be crucial if the Tempest hopes to keep pace with China and Russia, who are also developing powerful new jets. Still, not everyone is pleased about Japan's more ambitious military plans. Kyoji Yanagasawa, a former defense leader, is one of the few who have spoken out. He says that having more potent weapons will not scare away enemies. Instead, he thinks Japan should focus more on talking and making peace to avoid wars. Yanagasawa worries that if Japan builds up its army too much, it could cause more trouble than it solves. He believes that growing the military might deter neighboring countries and make Japan a more attractive target. His view focuses on the difficult choice Japan faces: how to maintain safety without exacerbating tensions with its neighbors. Many experts believe Japan's push to enhance its military capabilities stems from a rapidly changing world. With China growing stronger and North Korea building up its nuclear weapons, Japan feels it might be left exposed. There are also concerns that the United States, Japan's largest ally, may not always be able to fully protect it, especially if problems erupt in different parts of the world simultaneously. The debate over Japan's new defense plans shows the complex situation the country faces as it seeks to strike a balance between peace and security. While many people agree that Japan should be able to defend itself more effectively, others are concerned about potential future developments. If Japan overextends its military, will it truly make the country safer, or will it merely add more tension to East Asia? Yasuo Hasebi, a constitutional law expert at Waseda University, mentioned how hard it is to know if a strike is truly preemptive until after it happens. He also argued that the government could claim that simply possessing these weapons for defense, even if they are never used, still aligns with Japan's peace-focused constitution. Although the law isn't clear on the matter, the government firmly insists that its plan is legal. Hasebi noted that because the government claims it is allowed, questioning it becomes very difficult. Surprisingly, there has been little resistance from Japan's public, media, courts, or opposition parties regarding whether this new military path aligns with the Constitution. The government has also not clearly explained how its actions comply with the law. From the U.S. perspective, Japan's growing military presence can be viewed in two ways. Zach Cooper, a senior fellow at the American Enterprise Institute, notes that Japan is bolstering its weapons and defenses, which the U.S. already supplies through its alliance with Japan. He believes part of the reason is Japan's fear that America might not always be a steady partner. That fear partly comes from the time when President Donald Trump questioned the value of old alliances. Japan's plan also shows that it learned from Ukraine's fight against Russia. Experts believe that when a country demonstrates its commitment to self-defense, its allies are more likely to step in and provide assistance. Japan hopes that by demonstrating its ability to stand up for itself, it will receive even more substantial support, especially from the United States. The U.S. has revealed a new nuclear bomber built to outmatch the defenses of its rivals. For over 70 years, the B-52 served as a symbol of American air power, known for its massive payload capacity of up to 70,000 pounds and versatility in missions ranging from strategic bombing to maritime patrol. Yet this new bomber is more than a successor. It's a revolutionary force. Built with advanced stealth technology, unmatched range, and the power to deliver next-generation weapons, it raises the question: can this bomber truly evade the most advanced air defense systems of its rivals? Could its introduction provoke an intense arms race, pushing global powers to accelerate their military strategies? Join us as we explore the next-generation features of the U.S. Air Force's brand new nuclear bomber. For years, the mighty B-52 nuclear bomber represented American strength, carrying huge bombs and handling tough missions. But as other countries sharpened their defenses, it became clear that the United States needed something even more powerful. And that was how the B-21 Raider was born. As the U.S. Air Force's newest and most advanced nuclear stealth bomber, it is equipped with the impressive capabilities to sneak past advanced radars, launch cyber attacks, and strike targets from far away with precision. Recently, the first in-flight photos of the B-21 were released, showing the aircraft soaring through the skies over Edwards Air Force Base in California. This was an exciting moment as it confirmed that the B-21 had officially begun its flight tests. According to Andrew Hunter, Assistant Secretary of the Air Force for Acquisition, the tests are going well. He explained that these tests are helping the Air Force learn more about the aircraft's unique abilities. The B-21 Raider, named after the Doolittle raid of 1942, is not just any bomber, it's designed with futuristic features. This bomber can carry both nuclear and conventional weapons, making it more advanced than any other bomber currently in use. Its sleek design and advanced stealth technology allow it to evade enemy radar, giving it a big advantage in high-threat environments. This means it can reach deep into enemy territory without being easily detected. Details about the B-21 Raider are mostly top secret. Information like its size, speed, engine type, and the weapons it can carry remain hidden. Even its onboard sensors and the technology that helps it stay undetected are not fully known. However, it's clear that the B-21 has advanced stealth abilities. It has been designed to hide from radar with smooth edges and special cockpit windows that minimize seams and joints. These features help the aircraft stay hidden from enemy detection. It's also known that the B-21 can carry nuclear weapons, making it a powerful tool for the U.S. military. The B-21 is expected to be the first sixth-generation warplane in the world. Back in 2010, its price was estimated at around $550 million per unit, but after adjusting for inflation, it is now closer to $750 million per plane. While this is a hefty price, it's still cheaper than the older B-2 bomber, which cost $2 billion each. The lower cost is due to new radar-absorbing materials that reduce maintenance needs, as well as more efficient and affordable aerospace technology developed over the past 30 years. Plus, the Air Force plans to build 100 B-21s, far more than the 20 B-2s that were made, helping to reduce costs. Despite the B-21's advanced features, its exact costs are still kept secret, even from some members of Congress. This high level of secrecy has led to criticism from lawmakers, including the late Senator John McCain, who worried that defense contractors like Northrop Grumman might overcharge the government. There are concerns about whether the project's secrecy is necessary or if it hides potential cost issues. In fact, the B-21 Raider is one of the most secretive aircraft ever built, and there's a good reason for that. In 2009, the Joint Strike Fighter program, which created the F-35, faced a major security breach. Hackers believed to be Chinese agents accessed sensitive data. Just a few years later, in 2012, China showed off its J-31 fighter jet, which looked suspiciously similar to the F-35. Many experts think the Chinese used stolen F-35 designs to help build their jet. To avoid a similar mistake, the U.S. is keeping the B-21's details tightly under wraps. But regardless of the secrecy surrounding this bomber, its capabilities are impressive. It can hit targets deep inside enemy territory that were once thought impossible to reach. On top of that, it can act as a SIGINT platform, gathering intelligence from high altitudes over long distances. Some experts believe it could also take on airborne early warning and control missions, like what the Boeing E-3 does now, but with much better survival chances. Another impressive feature of the B-21 is its range. It can travel long distances without needing to refuel, making it capable of reaching far-off targets. This extended range is crucial, especially if missions need to be carried out quickly and from a distance. The B-21 Raider is also cost-effective compared to past bombers. While the exact price is classified, the U.S. Air Force has worked to keep its costs under control. This careful budgeting means that the military can build a large fleet without overspending. The design of the B-21 is focused on future needs. It can be upgraded easily with new technology, ensuring it stays advanced for decades to come. The military calls this a digital bomber because of its advanced computer systems and ability to update as technology improves. The B-21 Raider's role is not just about fighting wars, it's also about deterrence. By having a strong and advanced bomber fleet, the U.S. aims to prevent conflicts by showing strength. Knowing that the U.S. has a powerful tool like the B-21 may discourage potential enemies from causing trouble. Also, the B-21 isn't just a lone wolf. In battle, it can work closely with other advanced planes, like the F-35. Its advanced guidance systems can direct weapons launched by F-35s to their targets. This teamwork makes the B-21 a key player in network-centric warfare, a strategy where different military assets share information in real time to outsmart opponents. One of the most groundbreaking features of the B-21 is that it can be flown by a pilot or controlled remotely. If a mission is too dangerous, the United States Air Force can operate the B-21 without risking a pilot's life. This level of flexibility is unmatched by any other bomber in the world. Other countries are paying close attention to the B-21's development, especially China. Chinese researchers claim their hypersonic missiles, which can reach speeds of Mach 6, could take down a B-21 during a conflict. However, the B-21's stealth abilities are designed to make it nearly impossible to lock onto, even for advanced missiles. With the B-21's impressive capabilities, questions are surfacing about the B-52's future. Will it be retired alongside the B-1 and B-2, or could it find a new role within the U.S. Air Force? To answer this question, think of the B-52 as a big delivery truck and the B-21 as a stealthy aircraft. The B-52 can't sneak into heavily defended areas, but it can carry a lot of missiles and fire them from a safe distance. On the other hand, the B-21 is built for sneaking past enemy defenses and hitting targets directly. Looking back, the B-52 Superfortress has a long and storied history. Its development began in the 1940s, and the bomber first took to the skies in 1952 before officially entering service in 1955. Not long after the B-52 joined the Air Force, plans for a replacement began. The North American XB-70 Valkyrie project was launched in the late 1950s, with its first flight taking place in 1964. The Valkyrie was a marvel of its time, designed to fly at incredible speeds and altitudes. However, the project faced several challenges. Only 2 prototypes were ever built before the program was canceled. The high cost of production, combined with the development of advanced Soviet air defense systems, made the XB-70 less practical than initially expected. Around the same period, the Air Force tested another high-speed bomber, the Convair B-58 Hustler. The B-58 was the first operational bomber capable of reaching Mach 2, or twice the speed of sound. It seemed like a promising replacement for the B-52 with its sleek, futuristic design and impressive speed. However, it quickly proved to be a difficult and costly aircraft to maintain. The B-58 suffered from frequent accidents, had a high operational cost, and required a lot of aerial refueling, making it less efficient for long missions. Because of these issues, it was retired after just a decade of service. The search for a suitable replacement for the B-52 continued. The Rockwell B-1 Lancer was introduced as a blend of the B-58's speed and the B-52's long range and heavy payload. Unlike the previous attempts, the B-1 partially succeeded in taking on some of the B-52's duties. Its variable sweep wings allowed it to adjust its shape for better performance at different speeds, making it a versatile bomber. Despite its capabilities, only 104 B-1s were built. As the B-21 Raider prepares to enter service, the B-1 is expected to be the first bomber to be retired, a sign of how quickly military technology continues to evolve. Interestingly, the B-52 first flew 71 years before the B-21 Raider and just 49 years after the Wright Flyer, the world's first powered aircraft. This shows how long the B-52 has remained relevant and reliable. Its ability to adapt and evolve with new technology has allowed it to serve through decades of changing warfare. When stealth technology became a top priority for the Air Force, the B-2 Spirit was developed. The B-2 was a groundbreaking aircraft designed to be nearly invisible to radar while carrying a powerful payload. There were plans to produce many B-2 bombers to eventually replace both the B-52 and the B-1. However, the B-2 was incredibly expensive to produce and maintain. Each bomber cost over $2 billion, making it one of the most expensive military aircraft ever built. Additionally, the collapse of the Soviet Union and the end of the Cold War reduced the immediate need for such a costly bomber. As a result, the project was scaled back significantly, and only 21 B-2 bombers were ever built. Despite these efforts to replace it, the B-52 remains a central part of the United States Air Force's bomber fleet. Its durability, reliability, and ability to adapt to new technologies have earned it a reputation as irreplaceable. The fact that it has outlasted multiple attempts to replace it shows just how effective and valuable this bomber truly is. As the B-21 Raider steps into the spotlight, the B-52 continues to serve, carrying on its legacy as a symbol of enduring strength in the Air Force. The U.S. Air Force plans to bring the B-21 Raider into service around 2027, while the B-1 Lancer is expected to retire by 2036. Although the B-2 Spirit was supposed to retire soon after, the Air Force is investing $7 billion to upgrade the 19 remaining B-2s. These upgrades might keep the B-2s flying into the 2040s. Meanwhile, the B-52 Stratofortress is set to serve into the 2050s or even longer, meaning it will outlast three of its successors, the XB-70, B-1, and B-2. It's a strange idea to imagine the old B-52 flying alongside the new B-21 Raider. They seem like an odd pair, but they have different missions and strengths. The B-52 is cheaper to operate and can carry a heavier load. The B-21 is more advanced and expensive, designed for stealth missions where it needs to avoid enemy detection. On the other hand, the B-52 is a reliable workhorse that can deliver a massive payload. In a way, the B-52 has proven itself timeless, adapting to new technologies while still being practical and powerful. The Air Force's decision to keep the B-52 flying for so long shows how valuable it remains, even as newer bombers like the B-21 take on more specialized roles. Over the decades, the B-52 Stratofortress has undergone numerous enhancements to bolster its combat effectiveness. In 1971, the G and H models were upgraded to carry up to 20 AGM-69 SRAM nuclear missiles, significantly boosting their strategic strike capabilities. To further extend its reach, the B-52 was later equipped with air-launched cruise missiles. Following evaluations of the Boeing AGM-86 and the General Dynamics AGM-109 Tomahawk, the AGM-86B was chosen for deployment. This modification allowed 194 B-52Gs and Hs to carry 12 missiles on underwing pylons, with 82 B-52Hs additionally modified to house another 8 missiles on a rotary launcher within the bomb bay. Beyond nuclear armaments, the B-52's conventional warfare capabilities were also enhanced. 30 B-52Gs were modified to carry up to 12 AGM-84 Harpoon anti-ship missiles each, while 12 others were adapted for the AGM-142 HAVNAP standoff air-to-ground missile. These improvements enabled the B-52 to perform strategic attacks, close air support, air interdiction, offensive counter-air, and maritime operations. In the 1990s, the Conventional Enhancement Modification Program further expanded the B-52H's arsenal. This initiative integrated advanced weaponry, such as the Joint Direct Attack Munition, Wind-Corrected Munitions Dispenser guided bombs, the AGM-154 glide bomb, and the AGM-158 JSSM missile. Additionally, the program introduced new radios, integrated the Global Positioning System into the aircraft's navigation system, and upgraded the undernose FLIR to a more modern unit. By around 2010, the B-52's role shifted away from delivering nuclear gravity bombs and focused instead on nuclear cruise missiles and expanding its conventional strike capabilities. This transition was due to the aircraft's decreasing survivability against modern air defenses. Looking ahead, the B-52 is set to incorporate cutting-edge weaponry, including the AGM-183A air-launched rapid response hypersonic missile and the forthcoming long-range standoff nuclear-armed air-launched cruise missile. These advancements underscore the B-52's enduring role in modern aerial warfare. Right now, the B-52H bombers are being upgraded to a new version called the B-52J. These upgrades include brand-new Rolls-Royce F-130 engines, a variant of the AN/APQ-82 radar, and updated communication and navigation systems. Despite these improvements, the B-52J will still be very easy to spot on radar. However, even with its lack of stealth, the B-52J will still play a big role for the U.S. Air Force. It will likely act as a long-range missile carrier, able to fire advanced hypersonic missiles like the AGM-138 ARRW from far outside an enemy's defense zone. Meanwhile, the B-21 Raider will do the sneaky high-risk missions, getting close to heavily defended targets that the B-52 can't reach. This idea of using both the B-52 and B-21 together is similar to how the Air Force pairs the F-22 Raptor and F-15EX Strike Eagle II. The F-22 is built for stealthy, close-up combat, while the F-15EX can handle more straightforward, less risky missions. Now back to the latest U.S. nuclear bomber. One interesting fact about the B-21 is that some experts think the bomber could blur the line between a bomber and a fighter jet, possibly taking on air superiority missions. Despite being labeled a bomber with the B in its name, the B-21 is really a versatile, multi-role aircraft. That being said, the B-52 and B-21 represent two different styles of fighting. The B-52 is all about power and range, carrying heavy loads and firing from afar. The B-21 is about stealth, precision, and getting in and out without being seen. Together, they create a powerful team, balancing brute force and silent, high-tech strikes. The Air Force plans to officially deploy the B-21 Raider as soon as possible. Once it enters service, its primary home will be Ellsworth Air Force Base in South Dakota, where it will also serve as a training center. If needed, Whiteman Air Force Base in Missouri and Dyess Air Force Base in Texas will serve as backup bases. The Air Force believes that the B-21 will play a critical role in maintaining America's air power for years to come. What makes the B-21 even more impressive is that it's designed to handle the tough challenges of future warfare. Its advanced technology, including possible use of artificial intelligence for mission planning and coordination, shows that it's built not just for today, but for tomorrow's battles. The B-21 is part of the Air Force's effort to modernize its fleet, especially as older bombers like the B-1B Lancer and B-2 Spirit are set to retire. The B-21 Raider also highlights the strong partnership between the Air Force and Northrop Grumman, the company that built this incredible aircraft. Both are working hard to make sure the bomber meets its timeline and performs as expected. With its long-range strike capabilities and stealthy design, the B-21 could become a crucial part of the U.S. military strategy for decades. As the world waits for the B-21 to officially join the Air Force, many are curious about how it will compare to other advanced aircraft worldwide. With countries like China developing their own advanced stealth technology, the B-21 Raider will need to stay ahead to maintain its edge. According to reports, China is actively enhancing its nuclear bomber capabilities. The H-6N bomber has been observed carrying air-launched ballistic missiles, potentially hypersonic, significantly extending China's strike range and posing challenges to existing defense systems. Concurrently, China is developing the H-20, a long-range stealth bomber, although its progress appears delayed. These advancements are part of China's broader strategy to modernize its military forces and expand its nuclear arsenal. Recent reports indicate that China has nearly tripled its nuclear warhead stockpile since 2020. Additionally, the development of nuclear-powered aircraft carriers and submarines underscores China's commitment to enhancing its strategic military capabilities. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.